position. Everybody needs to be in center position. 100%. Thank you. Now, I'm going to ask a question. I'm going to ask one scholar to give me the answer. What did we learn yesterday in the previous lesson? Yes, Anaya.
Yesterday we learned the matrix. So I took notes yesterday.
Hold on, the matrix? Well, what is the matrix?
What you wrote on the board there.
And
That's the matrix.
And what did it describe?
It described when there's no solution, one solution, and infinite solutions.
Yes, and Diamond, she said, hold on, but she said that when there is one solution, no solution, or infinite solution. What is she referring to when it is, what are they referring to? What is it called in math that we learn about? Starts with E.
Equations, right?
Yes.
But I thought we were learning about how to solve linear equations without actually solving them.
Yeah, that's what we did because you
So
had to
we
figure
weren't
out.
learning- we weren't
Use
learning
the
the
matrix,
matrix
though.
though.
Well, yeah, that's what,
We were learning that's just a
that's
side.
true. That was a
Well,
side
I
thing.
learned the matrix because that's,
That's just an easy way to look at, but
so that's what I learned.
Joaquin, what can you tell me, when would we have one solution to an equation? Referring to the coefficient and the constant.
So, like, if we solve a problem and then I get like the,
Yeah, so with the
It's
coefficient,
without
when you
solving the
have,
problem.
Dan,
Yeah, you're talking that too.
when you have one solution, what happens with the coefficient? Are they the same? Are they different?
they would be the same.
They would be the same? Does anybody agree they're the same if we have one solution for coefficients for an equation? Nobody's agreeing there.
Sorry, what?
Nobody?
Oh, no,
You
no,
don't
they
think
would be
for-
constant.
For what? Oops.
There's two. Come on. What is a coefficient? Yasani, what's a coefficient?
The number before the sign.
The number before
The
the.
variable?
The sign.
The variable.
That is right, but you don't
Oh,
know.
sorry, I am talking out of turn. I apologize.
Okay. The coefficient is the number in front of the.
Variable.
Thank you. Variable. The constant is, Carlos, what is the constant then in math? What's constant? The number in front of the variable is the coefficient. What is the constant? Looking at the equation. You got it? No? Maybe Mo? That's how you got it? What is it?
Isn't it the number with no variable behind
It's
it?
just a number. It's just a number. And here, and I asked Joaquin, somebody to help him out, right? You want somebody to help you out?
What?
When would you have, referring to the coefficient, are they same or different? Constant, same or different? When you have one solution, what happens with the coefficient? Are they the same? Are they different? Isabella,
When you have one solution?
one solution. Is the coefficient going to be the same or different for one solution? Say it louder. That's right, different. And when, can anybody tell me when we have infinite solutions, what needs to happen with the coefficient? What needs to happen with the constant?
Oh.
Brianna.
For infinite,
Yes.
everything has to be the same.
But what is everything? There's two things.
The constants and the coefficients.
Are the same on the,
Both sides.
thank you.
Oh.
All right.
No, I thought when it was infinite, that just the coefficient, like the -1x and the -1x had to be the same.
The whole equation.
No, the whole, the,
No,
So
not
like-
all the time.
yes.
So
Oh,
that means
yes,
like,
never mind.
that means like it has to be like -1x plus 5 equals 5 plus -1x.
Whatever, when you combine like terms, just the coefficients have to be the same on both sides and the constant. So, I know what you're saying. It's like, so it's like 2x minus 3, right?
Yeah.
Then no matter what, let's say this is x plus x minus 3. Then just have to be the sum of both sides. This will be 2, right? 2x. And this is still -3.
That's what I'm saying, so
That
all
makes
have
it
to
in-
be the same? Oh, I didn't know that.
I
Yes.
thought that you were supposed to, oh, excuse me.
Yes.
I thought that you were supposed to combine all the, like.
Yeah, you will,
Like
yes.
x and 2x.
Yeah, you're right. No, but this is on this side, and this becomes, you're comparing sides. So if
But
they're
I
the
thought
same
you-
on both sides, look, if they're the same on both sides, does it make sense that both of them always be the same?
But my question was, I thought that you were supposed to combine all the x's.
You do.
Not just, so you didn't combine 2x with both those x's.
This is this is just one side. This has 2x, I'm combining this because I put x plus x, that's 2x to simplify.
So then you don't combine all the x's.
I'm unsure to say what, we're not solving, that's the thing, we're not solving.
But she wants to know if you solve it, when you solve it, do you add 2x and 2x and then?
Yeah, you try to
That's what
cancel it
she
out,
asked.
yeah. So this would be about trying to cancel it out, right?
No, that wasn't my question. I said that I thought that you're supposed to combine all x's, like 2x plus x plus
No,
x.
because it's in the other side.
On the same sides. Whatever you do to one side, you do to the other side. Like it's equal, that's what equal means. They're on the same on both sides, so you're adding like term on both sides. That's a good question though. I mean, with clarification. So we're combining this, if this was it, x plus x, 2x. But that's what we do. And if we wanted to solve it, if I wanted to subtract 2x here, I would have to subtract the same on both sides. I'd have to do the same on both sides to keep it the same.
Understand.
Okay? We have one more condition, right? The last condition is when we have no solution. When we have no solution, Adrian, when we have no solution, what happens with the coefficients? Are they same or different? Different.
Same.
Well, do we agree same or different when there's no solution? I see this. I see this. You want to change? So they're different, yes. Wait, no, they're the same. Sorry, same. They're the same. And the constants. What happens with the constants?
They're different.
Brianna.
They're different.
All right. No, but look, you can check it. Look, you can check it.
So do we have to check our work? Because that's kind of.
You don't have to really check it because you're not supposed to be solving anything.
When we solve the equation, are we supposed to check our work?
Yes, you should. All right. It doesn't matter. So these are the same. Now, it doesn't matter what number I put here, just as long as it's not negative 3.
Is this what we correct?
Brianna, Diamond. When this is the same, see? Same, they're going to cancel. And what do we left? Whatever numbers that are different. Negative 2 can't equal 5. It's not possible, so there's no solution. But what happens here? The coefficient's the same. The constants are different. You have no solution. Yeah.
Okay, so say they ask you to write the solution, like say they say, make a equation for no solution, right? So
Yeah.
basically, I would put like the coefficients, sorry, I'm kind of
Follow
confused.
them. Follow them.
Basically, I put the coefficients the same, so would this equation make sense? Negative 1x plus 5 equals 4 plus negative 1x. So that would equal to no solution, right?
Let's
And then I don't
see.
have to check it?
Well, let me see. What'd you say it again? Say it again.
Okay, negative 1x
Negative x. Yeah. 1x. What's 1x? Yeah.
plus 5
Plus 5.
equals
Equals
4 plus
4.
negative 1x, or
Plus negative 1x? Okay, just, you don't have to put it like that, but fine. So are the coefficients the same? Negative 1 on
Yeah,
the,
there would be no.
so this would cancel. Now you have a condition where 5 equals 4,
Mr. Q, sorry.
which is wrong.
Mr. Q,
Yeah.
You didn't have to do that.
I know, but I'm showing you the checks. You don't have to,
But
that's
I
true.
know, but since you're telling us to use the matrix and
That's
you're
the-
telling us
yeah,
to
that
solve
is-
it, the coefficients are the same as you can.
Trust, yeah, trust what you know, right?
so then, if we had to describe that, we would say, if we had to describe that, we would say because the matrix says,
No, that was just a word that, this is a matrix, this is what the diagram is. But don't you know, this is our simple way that I constructed after an hour.
Describe it like,
Coefficients are the same, constants different, no solution.
oh,
So it just has to have those conditions. Yes, Brianna, you had a question?
I said,
No, but you-
can I describe it by just saying, I know that this equation would be no solution because the coefficients are the same and the constants are different.
Yeah, because what, at the end, what are the,
So we're-
one more thing and then you can go on to the partner practice and stuff like that.
What? Oh, no, wait, sorry.
No, there's, okay, we did no solution, one solution, infinite solutions. Right? Now, remember what we did a few lessons ago, last week, right? Last week, look, what did we say? When no solution, A equals B. That's when, that means the constants. And when, what,
I
one
thought there was a
solution,
line through
X
it.
equals, well, I made a line through it, but they think, they're telling you that B is not the same as A. So when I put a line through it, that means A does not equal B.
Or can we just put A equals with a line through it and then A?
You can do that, yeah, it doesn't, but you just have to know that they don't equal. Now, when X equals something, like that's one solution, and infinite just means when A equals A, when both sides are the same. Now we started with that. Then we learned yesterday these conditions, and now you're gonna write them though now. You're gonna write
Like
just
what?
the equation. They're gonna give you give me an equation with two terms that has no solution.
Oh.
Then you just have to make the coefficients. You have to follow this. So coefficients the same, constants different. It will turn into, no, but you have to check it. I still want you to check it though.
So what is on one solution, the constant is plus over minus?
No, it can
Either.
be,
Either or.
the key to one solution is the coefficients have to be different. That's all.
Oh.
That's all. Doesn't matter. And if the
So the
constants
other
are,
side can be negative or positive. I mean,
The same or different?
yeah.
Mhm, it doesn't matter. Yeah, because it'll either be an answer or it'll be zero. The key
At
to,
first, when you drew this, I thought the positive actually meant like,
Positive.
I told you the key. Positive means they are the same on both sides. Minus means they're different on either side. All right, any other questions? All right, let's go into, so just practice. I'll go walk around.